Hello guys, welcome back. Today we are going to be going over the decoder circuit that I showed a little bit briefly last time but didn't talk any about. So let's go ahead and talk about how the logic of it works, and then we'll test it later and see that it actually does function as we expect it to. So right away we see that our memory address register, which we talked about last time, is outputting 4 inputs into this circuit. We see that each of these inputs goes to a NOT gate that is in our decoder circuit. So what we can realize is that for every bit in a byte, it is either on or off. It's either a 0 or a 1. What the circuit works to do is actually to enumerate all of those different possibilities. So for instance, if all of these bits are off, well then we'll have one of these outputs on. If only one of them is on, we'll have a different output that is on, and so on and so forth. So, and then let's look at these 3 AND gates. And all these AND gates are doing right here is saying that if these 2 inputs right here are both on, then this AND gate will be true, and so it pushes up to the next level. So then it checks if this AND gate is outputting true and this wire right here is true as well, or on, I should say. Then this AND gate pushes up and it checks again. So all these are really doing is making sure that all 4 of its inputs are on. You could really do this in a lot of times in schematics. You might see someone put 4 wires going into like an AND gate or something, and that's just a briefer way to make something like this. But I wanted to really spell it out so that everybody could see exactly what was happening. So let's go ahead and jump in. So I am going to have to control this memory address register in order to actually show how these outputs work. So I'm going to go ahead and turn on the setter as you saw right there, and then I'm just going to leave it on so that every time I make a different movement it will change. So right away what we see is none of our inputs for this circuit are on, and so we have this first output on. So then I'm going to go ahead and change one of our inputs. So now our last input is actually on, which has now changed which output we are turning on. And this is essentially how it goes for the entire remainder. I can switch 2 inputs. So we go there, change it again, and we basically do this all the way down where we're just iterating over every possible combination of inputs. So what this allows us to do, as we look right here, is we can have 16 different outputs and we can only choose one. And so the way RAM works is we actually create this grid, and depending on which inputs we have for both of our decoders, they will select one place in the grid where both of the wires are on, and that will be the byte that we are actually addressing in RAM. I'm going to talk about that in the next video. That will probably be pretty much it for the RAM, and then after that I'm going to be going on to the arithmetic logic unit. So as you can see, the RAM is really not that complicated. It's relatively repetitive, and you'll see that more once we get into the next video and I talk about all the bytes in the bus. But there's relatively few circuits that make it up. Now remember that we are only working on an 8-bit computer or architecture, so we can only address a maximum of 256 bytes, which I don't think I'm even going to get that much because the computer can't handle all of the meshes. But in an actual computer it's 64-bit, which if you do the math, you have the possibility of addressing 2 to the 64th locations, which is like 15 exabytes, which is a lot more RAM than any computer we have today is. And the reason for that is honestly we can't make RAM small enough, and we honestly have no reason to have 15 exabytes of memory right now. And so when they actually do their circuits, a lot of times they have a lot of these inputs as just, like, I think they say the first 15 inputs are just off because we don't have enough memory to fill up those locations. And what I mean by that is if you have 64 bits, the first 15 of those are just always off, and they never actually take advantage of having those extra zeros and ones, those extra enumerations to place memory because they can't fit enough memory in the computer. But I'm going to stop rambling and leave it here. Hope everybody enjoyed looking at this circuit. I think it looks quite pretty. Hope to see you next time. Bye.